Oh, I was hoping he'd say more about how young our speakers are, but apparently that doesn't apply anymore. Okay, so I get to speak about 3 things that are actually, each one of them, enough to fill a 45-minute slot. So I hope you don't mind if I go through things a little bit quickly. I'm going to speak about open source, Google's APIs, and my all-time favorite development tool, the Google Web Toolkit. So first, a little bit about how we use open source at Google and how much we love it and why. Then I want to go through kind of the breadth of the APIs that we have to offer, because the other sessions have gone in depth with just a few of the more than 30 APIs that Google has. And then the bulk of my presentation is going to be about Google's Web Toolkit, which is just a phenomenal tool that lets you write AJAX applications in Java and use all of the wonderful tools that comes with that. So no talk is complete without a cool picture. Here's my cool pictures. This is the original Google data center, complete with a Lego printer that I think Larry Page built up in the corner there. This is how our data centers looked somewhere in the middle of Google's short history. And this is how our modern data centers look. Ooh. As you can see, we have a lot of servers, and they all run Linux. That was my little segue here from cool pictures into open source. So how does Google use our open source? So for starters, pretty much all of our servers run Linux. We use Apache Tomcat in various places. We use SSH in pretty much all of our management tools. We use new project compilers when we write code. And most of our developers run a Google version of Ubuntu Linux on their desktops. And then if you go look in our source repository that we use when we write our products, we have hundreds and hundreds of libraries sitting there from open source projects. So why do we do this? Well, what's not to love about open source? For starters, it works pretty well, because lots of people have been part of making it work really well. But it has the effect that it does not make us dependent on third-party providers of software, right? Parties that could also be delivering software to competitors, or even worse, could one day become in a mindset that they're your own competitors, right? And so we have open source. When something does not work, because it's open source, we can just bring up the source, have our engineers fix the problems on our own timeline, right? So we become masters of our own destiny. We don't have to go persuade a third-party provider that a bug needs to be fixed and have that meshed into their release schedule, which could take forever. Also, if we want to do something unusual that requires a particular feature of a piece of software we rely on, we don't have to go tell someone about that particular feature, which could be showing our hands about our future products that could somehow make it into our competitors' mindset. And finally, and this is probably just as important as the other pieces, Google is very much about making the world a better place. It's not just about our own products, but we really, truly want to make the web a better place. We want to make technology better for everyone, and open source is very much about that. In fact, there was an interesting study a while ago where 2,000 or 3,000 open source developers were asked, why do you do this? Why do you release your code as open source? And perhaps surprisingly, the reason of disliking or distrusting proprietary software came in dead last. The reason people do this is because they find it stimulating, they find it improves their skills, they find they need it for their work. And like us, they find that the idealism around open source, around sharing things that benefit everyone, is very important. So here is a subset of the many things Google is doing to promote open source. We have released millions of lines of code ourselves as open source, and I'll go into that a little bit more later. We have donated millions of dollars to various open source organizations. We have a team that religiously ensures that we're consistent with the licenses that come with the open source software that we use. And also making sure that the licenses we provide with all of these APIs are consistent with open source. We take part in a lot of trade organizations. There's a page on code.google.com at organizations.html where you can see a long, long list of where we're helping out. We provide a lot of infrastructure for open source projects. Again, code.google.com, I think it's /hosting, is now the second largest repository of open source projects online. We have a strong involvement in the one laptop per child engineering effort, which is all about open source as well. And we have this amazing program called Summer of Code, which is a way we introduce students to real software development in the open source world during the summer. So this year, we had more than 6,000 applications from students around the world. They applied to work on particular projects with one of 1,000 mentors belonging to more than 100 open source organizations that had applied to be part of the program. And we approved, I think the real number is actually more like 900. This is a slightly old slide. We approved 900 applications. The student gets hooked up with a mentor at a particular organization to work on a particular project during the summer. Google provides a grant at the beginning, and with a successful completion, we provide another grant so that it's also a way for the student to make a little bit of money during their summer vacation. We call it our Flip Bits Not Burgers program. So a lot of code that we write at Google, we decide to release it as open source code. So you've already seen one example today, Google Gears. How cool is that? Offline web applications. I can't wait to go home and code some myself. The Google Web Toolkit that I'm going to show in a bit is also completely open source, the whole thing. Google Maps, which is my project, has started releasing utility libraries as open source. Lots and lots of things. If you go to code.google.com/hosting and search for label :Google, you'll see there's hundreds of projects that originated here at Google available as open source. And that was number 1 of 3. Thanks so much for coming, by the way, and even more so for staying until I got to be up here. So I had originally planned to make, say, 1 slide for every API that Google offers, until I realized that there were more than 30 of these, and I only have 45 minutes. So I just stuck them all on 1 page here. The ones I have bolded are the ones that people have already talked about here, or about to talk about: Gadgets, Google Gears, the Maps API, Web Toolkit I'm going to talk about in a bit. Data APIs comes a bit later. But there's lots of more stuff that you can go and grab and play with. Let's just take a few of them. The AdSense API. So AdSense is Google's way of letting you monetize your website by letting Google put ads on your website that match the content of your website. And when one of your users click one of those ads, Google gets paid by the advertiser, and we share that revenue with you. Now imagine that you're building a website that is based on user-provided content, like a blogger site, and you want each of your users to participate in an AdSense campaign just for their part of your website. You can use the AdSense API now to give your users the experience that they can go on your website, say a blogging site, create their content, sign up for AdSense all on your website, get Google ads next to their content, and when a user now clicks an ad, again, Google gets paid by the advertiser, but this time we split the revenue 3 ways between the user that generated the content, between you guys who wrote the website, and Google. The AdWords API. So AdWords is the program where advertisers can make advertisement campaigns on Google, either for use on our search engine or on AdSense pages. And some of these campaigns become very complex, and you can use the API if you want to provide a way for advertisers to make complex campaigns more easily. We have a desktop SDK. Google's desktop searches all the content on users' desktop hard drives, and you can write plugins that lets Google Desktop index more types of data there. We already heard about the Gadgets API. Google Checkout API, very powerful thing. If you're building a commerce site, all of that difficult work of accepting credit card payments and protecting yourself against fraud, and also giving your users the sense that they can safely go and buy something from you, all of that is taken care of by Google Checkout. I'm not sure it's actually available just yet in Australia, but I'm sure if it isn't, it will be. So the Checkout API lets you do quite a different set of levels of integrations of e-commerce into your website without having to do all of that very hard work. Google Gears API, how cool is that? Offline, I said that already, didn't I? The Maps API. So I want to just repeat something Alan said this morning, in case some of you weren't here. The Maps API was an eye-opener for Google in terms of APIs and developers and so on. It wasn't the first API that we released. It was maybe number 3 or 4 or so, but it was the first one that really captured developers in a big way. I think last time we counted, there are more than 50,000 websites now with a Google Maps on it. And we got just an awful lot of good press out of it and good attention out of it. In fact, it all started happening before we released the API. We released the API in response to developers just reverse engineering the Google Maps site to put a map on their own web page. And when we saw how good that was, just in terms of attention we got for Google Maps, we made this program available, and it took off like a wildfire. And certainly, when you look at the 2 years we've had this program out here, the majority of the positive press that we've gotten about Google Maps were really about mashups. And I think, I don't have a way to measure this, but I think that most of the people who go to Google Maps first saw Google Maps on someone else's website. And so it's just a tremendously beneficial thing for us and for Google Maps. And when it's happened, all of the product teams at Google notice this thing, and as a result, all of us, when we come up with a new project, we're always looking for that developer angle. How can we put an API on there so that developers can mesh it into their applications, and or so that developers can improve the experience of that product? And I guarantee you, this list here is going to grow very fast. Let's check my time here. Other things, you can build things around Google Talk using a standard XMPP protocol. You can extend Google's toolbars that sits on top of the browser. Lots of different feeds from search history. There's a API here up at the top where if there's an RSS or an Atom feed, you can grab that with JavaScript and mesh the resulting feed into your own website. The list goes on and on. I encourage you to go learn more about these. If you're building web applications, you can find it again on code.google.com/APIs, not surprisingly. OK. That was number 2. I should start my third part by saying that I don't work on the team that built the Google Web Toolkit. I had nothing to do with its invention or its creation or its forward development, which means I don't have to be modest about it at all. It rocks. Okay? I strongly encourage you, if you're building things on the web, to go have a look at it. I have spent most of my programming time the past 3 years writing one particular AJAX application, Google Maps. And it can be very painful, right? So for starters, when you write it, actually, let me just to warm you guys up a little bit. How many people here have written AJAX on the web? Yeah, how many people, if you were to update your resume today, would put AJAX on it? I'm always keen to see if more people raise their hand for my second question than my third question. Okay, that's good. So I won't go into a lot of details about what AJAX is and why and so on. It's a 2-year-old concept, and it's clearly, if not the long-term future, then at least the immediate future of the web building these things. And it can be pretty painful. When you build AJAX applications, you're really pushing the browser to its limits, or you're pushing the browser out to where browser incompatibilities are everywhere. And you end up writing JavaScript once, and you have to debug it 4 or 5 times in each of the browsers that you're targeting with whatever tools are available in that browser, right? So I think today, Internet Explorer has the best debugging setup with Visual Studio. Firefox comes in at a close second with the Venkman debugger, although a tool called Firebug is catching up really fast. If you're not using Firebug and you're writing web applications, you should definitely go check out Firebug. Safari, there is no debugger. It's about to change. They are working on it. But right now, you're stuck essentially with writing logging things in your code to see what's actually going on. And the same is the case for Opera. And it can take a long, long time. And there are no good IDEs that really support JavaScript. It's not because people don't like JavaScript. It's because it's a scripting language. It doesn't have the strong typing and so on that you really need to put together strong tools. The other problem is that scripting is really cool for getting things up and running very fast. You don't have to worry about strong typing. You can stick new properties on your objects without having to define them beforehand. So you can get things running really fast. However, when you want to do something real, where you need a big team to build it, like Google Maps is a sizable team now, it becomes really hard to work together when your compiler can't catch the kind of errors you have if you forget an argument to a function. The compiler can't necessarily catch it because it's perfectly legal scripting to do that, right? If you spell a property of an object wrong, the compiler can't catch it because it's perfectly legal that would be setting a new property on that object, right? And that becomes just really difficult when you have a large team. And the result is that even though you get started really fast, once you reach a certain stage in your development and your team reaches a certain size, everything slows to a crawl. So what is the solution to this problem? So GWT, the Google Web Toolkit, is a solution to this problem. I should be totally honest with you. I don't proclaim to know every other attempt at solving this problem. You need to go out and learn that from yourself. I have used the Google Web Toolkit now for a couple of months, and it's like night and day compared to the scenario I was talking about before. I often say that it's like returning to the 21st century, having been working in the dark ages for 2 or 3 years. It's a huge increase in your productivity to go this direction. So how does it work? With the Google Web Toolkit, you get to write your AJAX application in Java instead of JavaScript. With the Google Web Toolkit, you get to run your application in Java inside a real web browser that comes with the Google Web Toolkit. You get to run the Java code. You get to debug the Java code using whatever debugger you like that talks Java. And you get to make it all work in that environment. And then when you're happy with the result, you pull a handle on the Google Web Toolkit. It compiles everything into JavaScript that can run in a browser. And then the toolkit takes care of making sure that the JavaScript works across all of the browsers that you're targeting. Now, why would we do such a thing? So the GWT guys who wrote this, whenever they get a chance, they make it clear that they chose Java, not because they want to make any kind of statement about Java being the best or the only language or any such thing. The reason they chose Java as their starting point is that there's an enormous, an abundance of very powerful, very modern programming tools available when you write in Java. I'm going to do a little demonstration later just to show you one of those tools. I happen to use Eclipse, but there's lots of other choices out there. And you'll see how different it is compared to writing script in a plain text editor. Huge, huge difference. Now, the big benefit of writing it once and letting the Google Web Toolkit produce the JavaScript for you is that all of the browser quirks that you would otherwise have to deal with is now taken care of once and for all. And in fact, the way Grid works is very tight in that it actually produces a different set of JavaScript files for each of the different browsers. Okay? And during the startup phase of a Grid application, the system automatically, you don't have to do any work, picks the exact right file. I didn't do that on purpose. It picks the exact right file to you, so the code that has to travel on the wire is only the code necessary to make the application run in a specific browser that you're dealing with, as opposed to other solutions that might wrap browser incompatibility in a JavaScript library. You have to load all the code for all the different browsers into each browser every time, which is inefficient. The other thing, and I'm going to talk more about this later in more detail, speed is hugely important. So the folks who build this toolkit here are keenly aware that speed is as important as anything else you could ever do in your application. And they're constantly improving this thing, and I'll just leave it at that for now. I have a whole slide about that later, but this is very important. The toolkit comes with strong support for testing, for internationalization. I didn't do that on purpose either. And it has a very strong built-in UI library that you're not obliged to use, but it's there, and it's constantly growing because this is all open source, and it makes things a lot easier. But probably the key thing here is that by writing in Java, which is a strongly typed and very well-behaved language, you get to do a lot more code sharing. You get to scale your development team much easier without having to worry about the problems of developing script, right? All of those errors, which in the old AJAX world you had to catch during testing and at runtime, now a compiler will catch a lot of those errors for you much earlier on, which I'll show you in a minute. So here's the mission that the Grid team set out with when they started a couple of years ago, to radically improve the web experience for users by enabling developers to use existing Java tools to build no-compromise AJAX for any modern browser. So what's important about this? For starters, the overriding focus here is what comes out at the end of your development. If there's ever a choice between doing the right thing for the users of the applications you're building and making it easier for developers, we'll always choose to make the end application the best possible for the user, right? With the developer coming in at a close second. And as you will see, this is a very powerful combination. When they say no compromise AJAX, what they mean by this is that when AJAX first started appearing, there's a whole bunch of pitfalls that you have to avoid. Right? At the time AJAX started appearing, the web was mostly a tool for looking at documents, right? You would look at a document, click a hyperlink, new document would come in, and you could simulate an application-like experience with, you all know how that works, I don't have to tell you. AJAX came along, and it became very dangerous to forget the things that made the web as popular as it is, right? The fact that you can click on a hyperlink, go to someone else's site, hit the back button, and come back, right? The fact that you can do that a whole bunch of times and the browser keeps track of the history. That's incredibly easy to break when you write AJAX. And the Google Web Toolkit is designed to make it easy not to break all of those things, right? So that what comes out in the end is a very powerful, very slick application that still plays really nicely with the browser. Okay, speed. So if you're like me, and all developers, of course, are like me, if you're like me and someone tells you, hey, let's write AJAX applications in one language, and we'll have an automatic thing produce script that will run in browsers. The first thing that one would worry about is the speed of the result, right? Of course, if you are a top-notch JavaScript developer, if you have a PhD in browser quirks, you can probably squeeze out a faster application than anything automatically generated by a compiler. But only if you actually have the time to do that. And I mean both the time to learn this, and it's really hard, but also when you're in the process of developing, do you actually have time to do that level of optimization? Right? Because frankly, getting it to work at all in the old model of writing AJAX applications is hard enough. And I know this from our own experience. We probably have some of the best JavaScript programmers in the world on the Google Maps team. And there's tons of things that we know that we could do that would make Google Maps even faster. But we just don't have the time, because we also need to put out cool new features and so on. And it becomes this very difficult thing to deal with, because we have to go and program in this very difficult model of debugging in all these different browsers. With a tool like GWT, on the other hand, speed is built into the toolkit. So you can worry about, mostly, getting the thing to do what you want. And when you pull that handle, the toolkit will come out with a very fast set of JavaScript files. And over time, as the toolkit advances, the JavaScript will get tighter and tighter, right? Because with compilers, you can do things like unrolling loops. You can do things like inlining code. And you can encapsulate all the knowledge that you need to make the end application very fast into this one place, namely the compiler. And then the developers of a new application don't have to deal with that. And this is, GWT is now about a year old, and we've seen the speed increase quite dramatically every time the team puts out a new version of the compiler. The latest one came out just actually today, version 1.4. The size of the JavaScript that comes out of the compiler shrunk by 20%. The speed of starting up an application almost doubled, and that will just continue happening. Oh, and then it's open source. So this actually happened at the last version, 1.3, some months ago. It's licensed under Apache 2.0, which essentially means you can take the code and do whatever you feel like. You can make it close, you can make it open, you can send back your changes only if you feel like it. There is a page, again, on Google, code.google.com. You can go and learn about making the toolkit better. We have about 8,000 members of the development community using GWT to write applications, and about 300 or so are actively contributing code already, even though this was only open sourced a couple of months ago. And already in the first release after we made this open source, there's lots and lots of patches from external developers in the toolkit. Okay, so I've always wanted, this is like on my list of things to do before I retired, I've always wanted to write an application live in front of at least 500 people. And so today is my chance. I don't know what I did to the organizers to have them put my computer down here. You'll have to live with me bending over. So what I want to do is the shockingly difficult task of putting a button on the screen which, when you click, puts up an alert. I know this is not the hardest thing to do in the world, but I'm just trying to illustrate the development cycle when you use GWT. And so again, you get to write your code in Java. This is Java here. You get to pick whatever your favorite tools for writing Java is. I like Eclipse, and you'll see why in a second, but it's by no means the only choice here. So GWT comes with a command line utility that starts out an empty project for you. And here's the single Java file that comes out. It has a class called hello, which is my application that implements this entry point interface that just has a single method that gets run at the starting point. And so let's try and put a button on here. And notice how this wonderful tool here gives me auto-completion and automatically imported the right code here. Oops. There is a button. And now I need to put the button on the screen. I'm not going to explain exactly why This is the way that it works. Like that. So now you notice that I carefully and deliberately put a bug in there because I wanted to illustrate that if you had written the equivalent here, so this should be a lowercase b, not an uppercase b. If you had written this in JavaScript in your text editor, that bug would not have been found until runtime. That's just a feature of writing and scripting, right? With Java, that bug becomes caught by a compiler because this is not legal to do in a strongly typed language. Because Java is such a mature language and because there is such wonderful tools out there like Eclipse, not only does this get caught at compile time, but you can see my IDE actually catches it as I'm typing it. It tells me what I did wrong. It tells me what I did wrong. Like I said, live programming, one of the things I've always wanted to do. It tells me what I did wrong, and if I click the right thing, it fixes the bug for me. Okay, now try doing that with JavaScript. And again, this is not Gwt doing this for me. This is Gwt letting me write my application in Java, and there being wonderful tools out there available to write things in Java so that it can do this for me. So Eclipse, which is a great tool, does all kinds of things. You can rename a variable, and it finds all the places to rename. You can refactor your code. It does all these things for you. OK, let me try and run this. Here, button on the screen. Wonderful. So this is a browser. This is a real web browser. I'm running this on a Macintosh, but this is available on Windows and Linux as well. On a Mac, this is a Safari browser, or rather a WebKit browser that's built into the toolkit. On Windows, it's an IE browser. On Linux, it's a Firefox browser. It's a browser that has built into it the ability to run Java code. And you will see how that looks now. Suppose I wanted to actually do something. When you click this button here, add click listener, look at how it does lovely auto-completion for me. So now I need to implement the appropriate interface here. Oops. There we go. Again, the tool here just does everything for me, puts in the stub I need to implement here. This is how you put up a message box. There. OK, so I changed the code a little bit. And now watch the development cycle here. I save the code. I go to the hosted browser that's already running. And I just reload it. It takes a split second here. And the new code is in the hosted browser. OK, so even though you're writing this in Java, and even though the target output is JavaScript that requires a compiler, you can do incremental development by just reloading the Java code into this particular hosted browser here. And you can debug it as Java. Well, let me try in my IDE here to put a breakpoint and then start up the debugger. So again, I'm using the Eclipse debugger here, but you can use any debugger that can debug Java. There, and now when I click this button here, I'm in a debugger. I'm debugging at the Java level. I can inspect my Java variables, and everything is just as if I was writing in Java, because that, in fact, is exactly what I'm doing. There, let's just make that run to the end. Like this. OK, so you write your code, you run it in Java, you debug it in Java. When you're happy with it, which can be many cycles later, then you hit the magic button here. And that takes a couple of seconds. And the toolkit translates the Java into JavaScript. And now it's running in the browser. And it just works like this. And this will work in any browser. And even if I wrote an actual real application, it would work in every browser. OK. So when you get the toolkit, there's a couple of little toy applications as samples here This is a make-believe mail application. It doesn't actually have any kind of backend to it. But you can see that it's perfectly possible to make nice-looking applications with the toolkit here. This is done entirely with the UI library that comes with the toolkit. And one thing you can see here is that the styling is just like you would expect it to be in a web browser. So part of the no compromise that's in the GWT team's mission means that the JavaScript that comes out of the compiler generates HTML that's perfectly tight, legal, normal, standard compliant, and in particular, it's stylable with CSS. So when you put this button on the screen, that turns into an input HTML element that has a particular CSS selector on it so that you can write your style sheet just like you would any other HTML site. Another sample that comes with it is called the kitchen sink, which is really just an application that contains all of the different UI widgets that come with the toolkit, which is a growing list, of course, and third-party developers, you can find lots of widgets that didn't come with the toolkit natively. So it's got buttons, it's got checkboxes, it's got the tabs you can see up here. It's got a bunch of different panels that you can use to organize your widgets with. It's got lists. It's got text. It's even got, this is very hard to do. It's got a rich text editor like this that you'll need for pretty much any application that takes serious text input from users. It's got little pop-ups and not so little pop-ups. Here, whenever you want to show yourself showing a lightsaber to Jimmy Carter, you need a pop-up for that. A very important part I want to illustrate is history management. So I mentioned earlier how dangerous it is when you write an AJAX application to not respect the way the web works. So you can use the back and forward buttons to go through the history of your interaction with not just your website, but the entire web. And so in GWT, like in all AJAX applications, you're really staying on the same page throughout the entire experience here, right? So I clicked these tabs here, but it was the AJAX and dynamic HTML that flipped the tabs. It wasn't an actual page interaction like we did in the old days, right? And still, when I hit the back button here, you'll see that the browser can figure out going backwards and forwards in my history. And even if I go to some other website of choice here, this could have been me clicking a link in my application. When I go back where I came from here, that history is still there. Okay, so this is really hard to do, and is all done by the toolkit for you. The way it works is that you, as the application developer, decide what interactions that your user is taking should result in an entry in the browser's history. And you just make this call. You say, encode the current state of the application as a history entry, and give it some string that you can later use to recreate that state. So you'll see that the way it works is that that state gets appended to the URL like this. Okay, so when they wrote the samples, they decided that this particular state of being on the panels tab here should be just encoded with a string. Panels, you can decide on something more complicated. And this has the effect that you can bookmark this URL, and when you go to that bookmark, the application can recreate the state that it was in when the bookmark was created. It means you can copy the URL from the browser, send it to someone else, and when they click it, they will actually not just see the starting page of the application, but they will see the application in that state that it was in. And all of this is done essentially for free by GWT. Okay, so let's go back to my PowerPoint slide. Here. Not enough time to demo everything. So just to give you a quick rundown of a lot of good things in GWT here, it comes with a unit test system where you can write your unit test and have them automatically executed. Even in a cross-browser kind scenario, you can set up a couple of machines that actually runs in a production type environment with different OSs and different browsers on it, and Git can manage for you unit testing your things on all of those different machines remotely. There are occasions where you really want to write JavaScript. Like, imagine that you're writing some widget that you think lots of other people can take advantage of, and you want to make it really, really tight and efficient. It's very easy in Git to implement a Java function with JavaScript. There's just a special syntax for doing so, and then you're completely in control of what JavaScript comes out in the other end. You can wrap it up in Java, make it available to others to use without them having to worry about what scripting happens inside it. Cross-browser, we mentioned this already. It works in all of the modern browsers, IE 6 and 7, Firefox from 1 to 2, Safari from 2 and upwards, Opera from 9. When you're developing, you pick your favorite platform. Git is available now on Macs, which is what I use, on Windows machines, and on Linux boxes. You pick your own IDE. Anything that can speak Java will work with Git. Eclipse is just my favorite choice. Like this. I thought I wanted a slide that you guys can't read in there, just for good measure. So like I said, Git comes with a very rich set of user interface widgets and panels, growing all the time. It comes with a very powerful RPC mechanism, so libraries by which you can communicate between your application running in the browser and your server. There's actually quite a lot of choices here. If your backend speaks Java, you can have a serializable Java object in your server be transmitted on the wire and appear to you in the browser as that same Java object. Okay, so you can imagine how this works. You're writing a Java object, you're making it serializable, you're writing Java code that runs in the client. Of course, that gets translated to JavaScript, right? And so then what Git does is that it serializes the class, puts it on the wire, and it arrives on the other side in a way that the JavaScript that came out of the Java can interact with it in the appropriate manner. If your backend is not written in Java, there's very strong support for JSON communications with any server, for XML communication with any server, just using HTTP. Oops. I think I mentioned most of the things in number 3 here. Before unit testing, benchmarking for speed, which is a new feature, excellent history management, internationalization has strong support, and then all of the different things that you get in all of the standard libraries you get in Java, well, at least the ones that make sense, are emulated in this environment. So your strings, all of your different containers and utility functions are available. We've got a great guide to get yourself started with. We've got a widget gallery. This is all on code.google.com. There's a developer guide. There's a JavaScript class reference. And probably most importantly, there is a vibrant community of developers using this thing. I think I mentioned that there was more than 8,000 developers in our discussion group that you can ask for help from. Lastly, the Google Web Toolkit is a year old, launched pretty much exactly a year ago. And the team just sent me this slide just yesterday with a little retrospective here of what has happened during that year. And one very exciting thing is that all of the different main IDEs that speak Java, someone have put in particularly strong integrations into IntelliJ, into Eclipse, into NetBeans, and so on, where you get special support in the IDE for Git, including, I haven't tried this yet, but there are now WYSIWYG editors where you can drag and drop and design your UI in a graphical interface, pull a handle, and out comes a Git project implementing that interface. Major applications have been built with this tool over the last year. Google's base front end is built with Git. Google's checkout front end is built with Git. External places which you can't see here because I chose yellow for inexplicable reasons. But I'll just show you here, this tool here. These are real live applications running out there very fast using GWT, this cool thing here. And lots more coming without question. More than 100 projects on code.google.com are add-on libraries and projects related to GWT. There is a book out you can find on Amazon.com by the GWT inventors. And as Alan mentioned this morning, they went and counted, and they found that more than 1 million people had downloaded this development tool, which is really quite an astounding number since it launched a year ago. And that's all I have to say.